Welcome to aminacademy.com. In statistics, let us discuss about correlation and regression, some introduction. Correlation quantifies the strength of the linear relationship between a pair of variables, whereas regression expresses the relationship in the form of an equation. The word correlation is used in everyday life to denote some form of association. We might say that we have noticed a correlation between foggy days and attacks of wheeziness. However, that means foggy is more, wheeziness also more. Number of people it affects. However, in statistical terms, we use correlation to denote association between two quantities variables. We also assume that the association is linear, that one variable increases or decreases a fixed amount for the unit increase or decrease in the other. The other technique that is often used in these circumstances is regression, which involves estimating the best strength line to summarize the association. Correlation and regression are the two most commonly used techniques for investigating the relationship between quantitative variables. Here the regression refers to the linear regression. Correlation is used to give the relationship between the variables, whereas linear regression uses an equation to express this relationship. Correlation and regression are used to define some form of association between quantitative variables that are assumed to have a linear relationship. Now we define the correlation. Correlation can be defined as a measurement that is used to quantify the relationship between variables. If an increase or decrease in one variable causes a corresponding increase or decrease in another, then the two variables are said to be directly correlated. That means one increase, other increase, and one decrease, other quantities also decrease. This relation is directly correlated. Similarly, if an increase in one causes a decrease in another or vice versa, then the variables are said to be indirectly correlated. If a change in independent variables does not cause a change in the dependent variables, then they are uncorrelated. Thus, correlation can be positive or direct correlation, negative or indirect correlation, or zero, there is no correlation. This relationship is given by the correlation coefficients. Now we will define a regression. Regression can be defined as a measurement that is used to quantify how the change in one variable will affect another variables. Regression is used to find the cause and effect between two variables. Linear regression is the most commonly used type of regression because it is easier to analyze as compared to the rest. Linear regression is used to find the line that is the best fit to establish a relationship between the variables. That means through the given variables we can get a best fit straight line which indicates a regression line. Correlation and regression analysis. Both correlation and regression analysis are done to quantify the strength of the relationship between two variables by using numbers, graphs. Graphically, correlation and regression analysis can be visualized using scatter plots. That means the given quantities are plotted in a graph and dots are more there described. That is a scatter plot. That means each point represents some relationship between two points. That means here collectively the regression points is called a scatter plots. Correlation analysis is done so as to determine whether there is a relationship between the variables that are being tested. Furthermore, a correlation coefficient such as Pearson correlation coefficient, we will discuss later, is used to give a assigned numeric value that depicts the strength as well as the direction of the correlation. The scatter plot gives the correlation between two variables x and y for individual data points as below. Look at here, this graph in XY plan we are putting dots regarding the given relationship, given points, given data. We put a dot, plot a dot, and it shows some correlation nature. Regression analysis is used to determine the relationship between two variables, such as that the value that the unknown variables can be estimated using a knowledge of known variables. That means one variable is given, regarding that the other variables how it is related, that is called a correlated. The goal of linear regression is to find the best fitted line through the data points. For two variables x and y, the regression analysis can be visualized as follows. Here in plotted regression plots, that is the points are plotted. Now we have to draw a best fit line. That means all lines are mostly nearer to the plotted points. That is this straight line is called a best fit regression line. Correlation and regression formula. Here the linear correlation coefficient for a collection of n pairs of xy of numbers in a sample is the number r. That is correlation coefficient, we let it is r, is given by the formula r equal number into sigma xy minus sigma x into sigma y and divided by square root of n into x square minus sigma x whole square into n into sigma y square minus sigma y whole square. Here n is number of data in x or y, number of data is n. Here xy, sigma xy means multiply x data x and y and add up together, sum together is called sigma xy. Here sum of x together sigma x, sigma y is sum of y together. Here like the tables, x square we have to calculate for each x and sum it is sigma x square, like sigma x whole square, that is sum the x whole square into n number of data into sigma y square minus sigma y whole square, like x here y is. Here if the r, that is sigma, I can write this is, if it is negative values it's called negatively correlated. If it is between, this is between, of course minus 1 is this is negatively correlated, this is negatively correlated with minus 1 to 0, and here it is a positively correlated, that is p is, that is rho is greater than 0, less than positive 1. Here p is positive 1, this is a positive correlated, this is a negative correlated, here positive correlated. Here there is no correlation, it is harder to draw a straight line, best fit line between, because these points are most widespread. That means we cannot assume the best fit line here, so it is a zero correlation. Correlation and regression are both used as statistical measurement to get a good understanding of the relationship between two variables. If the correlation coefficients is negative, that is, or positive, then the slope of the regression line will also be negative or positive. That means its slope says it's a positive or negative. That line have positive correlation or negative correlation. The table given below highlighted the key difference between correlation and regression. Here, the correlation is used to determine whether the variables are related or not. Correlation is, we are understanding from the correlation we can say it is related or not, both variables are related or not. Regression is used to numerically describe how dependent variables changes with a change in a independent variables. That means it is says it is related or not, but how it's related means by numerically negative, positive or 0 we can understand from the regression. That means by using the formulas we have to find the coefficients, and from that regression is, we notice that it is how it is related. Correlation tries to establish a linear relationship between variables. That regression finds the best fitted regression line to estimate as and unknown variables on the basis of the known variables. Here the correlation variables, the variables can be used interchangeably. That means here and here change it. The variables cannot be interchanged. That means x and y is not interchanged. As it is, you have to use it here. Correlation uses assigned numerical values to estimate the strength of the relationship between the variables. Regression is used to show the impact of unit change in the independent variables on the dependent variables. Here the correlation coefficient, like for example the Pearson's coefficient is the best measure of correlation. The regression, the least squares method is the best technique to determine the regression line. Some important note against correlation and regression. That means, but summarize all the points what you explained above is here. Correlation and regression are statistical measurements that are used to quantify the strength of the linear relationship between two variables. Correlation determines that if two variables have a linear relationship, while regression describes the cause and effect between the two. The reasons you can understand why it is not related, why it is related, linearly related, not, it is not, we can understand by using regression relationships. That means next is Pearson correlation coefficients and ordinary least square method are used to perform the correlation and regression. So far we discussed the above is only correlation and regression, that introduction points and some ideas about it. In future videos we will discuss further about correlation and regression, how to calculate, what's the difference between them, how it's affect one another, we can understand. We have done. Please subscribe our YouTube channel.